What I have here is dry ice. Now, dry ice, okay, is CO2 in the solid phase. Now, normally CO2 is in the gas phase. Now, why? Its boiling point is very, very low. So, normal temperatures for us, it is already boiled. Now, the thing is, okay, dry ice has something called a triple point. That triple point is where you have solid, liquid, gases in all three phases of matter. The place where you have a triple point is actually at 5 atmospheres. What that means for us is, in order for CO2 to exist as a liquid, we would need atmospheric pressure to be 5 times greater. The pressure pushing down on this solid isn't great enough to keep it into a liquid form, so it goes directly to a gas. It sublimes. And as you watch, you can see that the dust here, okay, it's getting dusty as it's losing its solid. And if you look carefully, you can actually see someone said steam, but you don't actually see steam as we talked about. You see fog coming off of it. Okay? Now, I'm going to cut it. CO2 is carbon and it's oxygen. It's nonmetals. What do we know about nonmetals compared to, let's say, metals or ionic compounds? What kind of solids do they make, if they make solids? Think about a stick of butter. Brittle, right. So let me cut this. Okay? And as you can see, it's very brittle. Okay? Very brittle. And the reason why it's brittle is because things that are molecular, things that are bonded, okay, covalently have local bonds. You put stress on them, the bonds break. Remember we smashed a racquetball?
Yes. Yeah.
We cooled it down, it lost its flexibility, we applied a stress to it. Where did it stress? It stressed where the bonds were. You can't do that normally to steel, okay, because it's attracting electrons in all directions, metallic bonding. So, interesting enough, this thing sublimes at approximately negative 80 degrees Celsius.
What do you mean by sublime?
Sublime means it going from a solid to a what? Gas. So there's no liquid here. This is, quote, melting or subliming. It's going directly to a gas. It's never going to see a liquid. The pressure is not high enough to force it into a liquid. Now, what's the reasoning? Why does CO2 sublime? Because is CO2 a polar molecule or a nonpolar molecule? What kind of attractive forces do we have between them? Weak. We call them the weak forces in New York State, but everyone calls them London forces. And they're weak. So they're so weak, these solids don't attract each other so strong, so they jump into the gas phase. Now, if I had some warm water, okay, we can do that very simple demonstration that every science show does. Okay, they put some warm water, okay, up somewhere. Okay, not that close. We're getting too personal there. Okay, and you put some warm water into a beaker, and you drop some dry ice. Okay, and you get this effect here. And what you see, okay, is nothing more than.
Oh, that's pretty cool.
And what's interesting about this, you would suffocate because there's only CO2 gas. The dry ice, which is CO2, hits the warm water and it's forcing it to sublime. Okay, we're giving off CO2. This cold CO2 makes the water vapor condense. What's interesting, though, is CO2 is more dense than air. So you can actually pour the CO2 out like you would pouring a drink.
That's pretty cool.
Now the water vapor is going with it. Okay? Now, so yeah, they use CO2 fire extinguishers because it's more dense. Now we're gonna do something else with this, though.
Can I touch it?
Yeah, I'm gonna give you little pieces to play with. Okay? No, I'm gonna give you pieces. Now, what I want you to do with the pieces is I want you to.
So if we ate it, we would die?
You would freeze your esophagus. What I want you to do is take the pieces I give you, and I want you, the pieces I give you, try to play a little ice hockey.
Play ice hockey?
Yeah.
Joey, don't be so, okay?
Now, if you notice, these things actually fly easy on the table. Why?
Because they're crazy. They're little jumbo beans.
No. When they hit the warm surface, the solid becomes a gas. They're pushing a gas downward. If you play ice hockey or air hockey tables, the air pushes up on the disc and does what? Supports it. So this is going to float like an ice hockey table So I'm going to give you a little piece to play with now. Now, careful, it's -80, so if you keep holding it, you'll give yourself frostbite.
So let's not.
Okay, so I'm going to throw it to you on the table, play it back and forth, and because of the sublimation back and forth, you're going to be able to play a little ice hockey back and forth. You can't hold on to it long, okay?